In our last video, we did these first 3 examples where we were evaluating some limits that happen to have some infinite limits. We also found some vertical asymptotes. In this video, we're going to do the final 2 examples. These final 2 examples, they involve trig functions. So let's jump right in and see what we have. So here we have 2 over sine of x. And so we will have a vertical asymptote whenever the sine of x is equal to 0. So when is the sine of x equal to 0? All right, so when is sine equal to 0? Sine is equal to 0 at 0 itself. Yeah. It's equal to 0 at pi, and at 2 pi, and at 3 pi, and at 4 pi, and 5 pi, and 6 pi, and 7 pi, and 8 pi. This function is going to have a vertical asymptote at every single multiple of pi, integer multiple of pi. Right? So there is a vertical asymptote of n pi for every single integer n that you could pick. We are also asked to find this specific limit, the limit as x approaches 0 from the right. As our x value is approaching 0 from the right, that value x is getting closer and closer to 0, but it's positive. So then the value of sine of x, it is getting closer and closer to 0 as well. And that is also positive when we are approaching from the right-hand side. So we have 2 over some really small from the right-hand side. Whew. Oh, man. I'm speaking wrong. So as we approach 0 from the right, oh, no, that's okay. 2 over that, we are going to get infinity. Sine of 0.001 is going to be a really small positive number, and yeah, looks good. Let's look at this other example. Here we have x plus 2 over cotangent of x. Where are we going to have issues here? Where do we have vertical asymptotes? So we will have vertical asymptotes at x equals, so whenever cotangent is 0, and cotangent is 0 at all of the odd multiples of pi over 2. So to describe those, we're going to say we have an odd number, and every odd number we can describe as being one more than some even number. So it's an odd multiple of pi over 2 for every integer n. And if we were to plug in 0 itself, cotangent of 0, we are going to get that limit is 0 itself. Great. And that is it for infinite limits. In our next video, we will start talking about derivatives. We will see you there.